Wasabi, you guys. Welcome to Integration B for Intermediates Part 9. In this easy section, it's just power substitution, and we're just gonna sort of practice our way into applying power substitution. So let's go ahead and get right into it. So power substitution is pretty much a type of force U substitution where the whole point is just to get rid of radicals. That's pretty much it. The whole point is just to get rid of radicals. So, one way is to do trig sub, right? But if you're really lazy, we just do power substitution. In this case, to get rid of this, I'm going to let u equal the square root of x minus 1. And then u square is x minus 1. U squared plus 1 is equal to x. And then derive both sides, you get 2u du equal dx. And so, x is u squared plus 1. Dx is 2u du. And then x is the square root of x minus 1. And it's just u. So that cancels out. This is super easy now. So this is just to integrate this by power rule. This is u cubed over 3 plus u. So now we have 2/3 of u. U is square root of x minus 1 plus 2u. And that's all we have to write. And that's it. Very, very simple. So now what about this integral? Again, I want to get rid of the radicals. I just want to get rid of the radicals. This is okay. So I'm just going to let u equal square root of 1 minus square root of x, so that u square is equal to 1 minus square root of x. This is u square. I'm sorry. I'm going to replace that with 1 minus u square. X is equal to 1 minus u square squared. And then dx would be 1 minus u squared times 2u du. And so now we have u, we have du, which is 4u, 1 minus u squared du, and x is equal to 1 minus u squared squared. So this cancels out, this whole thing cancels out. We're left with 4 u squared 1 minus u squared. We've seen this. We've done this so many times. So in that case, we would just do pretty much minus 1 plus 1, right? So we get 1 minus 1 over 1 minus u squared, and then minus 1 du. And so now, this is just 4 inverse tanh of u minus 4u. And so now our answer is just 4 inverse tanh of square root of 1 minus square root of x minus 4 square root of 1 minus square root of x plus c. Okay? Oh god. That's a cube root. That's nasty. What do we do? How do we get rid of this? We just do like we always do. We just get rid of the radical. So we let u cube equal to x, right? So that when I plug u cube in here, it just becomes u. And now 3u squared du is equal to dx. And so now we have from 0 to 1 du 3u squared, and then 1 plus u. If you remember, this is pretty much geometric polynomial division. Right, that's a 1 plus u. So that means we would sort of subtract. So this would be, let's see, 1 plus u, so that's plus u. So it'll be u minus 1 plus 1 over 1 plus u. Right. And to easily see that, I'll actually, let me put this in a different color. To easily see what's going on, right? This is pretty much you're doing plus u minus u here, and then minus 1 plus 1. And that's how you get this. Okay. That's the idea. So but that's a geometric polynomial division. And now this is very easy to solve. This is just 3 u squared over 2 minus u plus ln of u plus 1 from 0 to 1. Be careful that's not 0 because, oh, well actually, yeah, it is 0. Plug in ln of 0 plus 1, that's ln 1, 0. Okay, cool. So then in that case, we just plug in 1. This is a half minus 1 plus ln of 2. So this is 3 ln of 2. And then this is negative half minus 3 halves. This would be our answer. Oh god, there's two different radicals. A square root and a cube root. What do we do? What do we do? So then you need to find a power of u that we can plug in x such that this cancels out and this cancels out. So what exponent do we use to cancel out this cube root and square root? To cancel out both simultaneously, we need an exponent that that's a cube and a square. So that means that we need 2 times 3, 6. So we use u to the power of 6. And we derive it. And now we get 6u5 du. U to the power of 6, that's u cubed. U to the power of 6 in here, that's u squared. Ah, you can cancel it. There's so many cancellations. Beautiful. Divide everything by u squared. And you get u plus 1, and then u cubed. And most commonly, we get a geometric polynomial division. So now this is just, let's say, u cubed. So it's u squared minus u plus 1 minus 1 plus u, which is what we get. If you want to double check, you can just go u squared minus u squared minus u plus 1 is minus 1, which is what we get, right? And then you factor pretty much u squared, u plus 1, that cancels out, and that's where these comes from. But that's we already learned that from our past video, from our beginner training. So polynomial division, I forgot where I'm still in blue. I'm just gonna recover that. Don't do this with markers, with expo markers, don't do that. But here, this is just 6. This is gonna be a nasty answer. U cubed over 3 minus u squared over 2 plus u minus ln of 1 plus u. I should have made this definite, but that's okay. U is equal to this x to the power of 1/6. That's why it's nasty. So to remind you, u is equal to x to the power of 1/6. So this whole answer, this is like, I can use this to cancel some out. 2x 3 to the power of, I'm sorry, 3 over 6, that's a half. 3, let's see, u squared, that's 1/3. And then plus 6 to to the power of 1/6 minus ln of 1 plus x to the power of 1/6. And this would be your answer. So with this integral here, you can do u equals x minus 1, but you see, I don't like fractional exponents. So if you like fractional exponents, you can go ahead and do the power rule. But as a lazy person, I'm gonna go x minus 1 to the power of 6. u6 equals x minus 1, 6u5 du equals dx. So now plug in 2, that's 1, plug in 0. Plug in 1, that's 0. And so now we have 6u5, x is equal to u6 plus 1, and then u du. You see, I like this better. So now this is just 0, 1, and then this is just 6u6, u6 plus 1, which is equal to 12, 6 du. With power rule, this is going to equal like 6. 1 over 13 plus 1, 7. Something like that. I would just leave my answer like this. I wouldn't, you know, I would just leave my answer like this. Okay? Oh god. Fractional exponents. We get rid of the fractions. We got to get rid of the fractions, and we do that by letting u cube equal x. Okay? And now we have 3u squared du equal dx. So now it's 3u squared du, and then x equals to u cubed. This is u squared plus, and then u4. This is equal to 3, 1 plus u squared. Oh wow, look at that. That's super easy. Easier integral. So now this is just 3 inverse tangent of u. U is equal to the cube root of x. And that is our answer. Oh god, again, this looks terrifying, it looks awkward, but we just gotta get rid of the radicals. However, we have a mixture of square roots and cube roots. So how can we get rid of both? We let x equal u to the power of 6. So that now that would cancel out the square roots and the cube roots. So dx 6u5. And so now square root of u to the power of 6, that's u cubed, times 6u5 du. And then here, u cubed minus u squared. Simplify it. This just cancels out u squared. So we get u minus 1. 6, that's u to the power of 8. 8 minus 2, u6 du. Oh god, we have a very long answer. Geometric polynomial division, we get u5 plus u4. Because this is minus 1, this is all going to be positive. 3 u squared plus u plus 1 plus 1 over u minus 1. Okay. Oh god. That is how it works, I believe. Right. You do u5 plus u5 minus u4, and this will always be positive. Yeah. So cool. So now that we got all this whole chain, this geometric sequence, geometric series, not a geometric series, but it's you know how this is. But you could just, it's just power, just straight up power rule. So I'm just gonna put parentheses and go like this, and then, oh, I forgot our answers in U form. Disgusting. Disgusting. Well, we didn't have a choice, so let me just put in some more room. Okay, so now this is just, remember that U was equal to 1 over 6. So we have x, pretty much this is x, plus 6/5 of x 5 over 6. You just leave it like this, honestly. I'm too lazy. This is 2.5. You notice a pattern that this is the reciprocal. The coefficients are very reciprocated, right? You notice a pattern, and then 6 ln x to the power of 1 over 6 minus 1 plus c, so that you guys don't get triggered. And this is my answer. And there you go. Oh shiz, it's MIT time. So we have an MIT integral here. So what do? Well, this is just 1. Don't let these numbers distract you. Yes, it's a Pythagorean triple, but let's not let that distract you. Let's not get carried away. So we're gonna let u equal 25x. Sorry, u to the power of 25. Then 25 u24 du is equal to dx. And then 25u to the power of 24 du. This here, this is going to be u25 times u to the power of 16 plus u to the power of 9. Okay. Unfortunately, we can only take out 9. So let's go ahead. What's 24 minus 9? That's 15. Is it 15? I guess it's 15. Okay. 25 u15 du. Oh god. And then this is 1. And then here, 25 plus 16. They're giving us hella nasty numbers. But then I have to do minus 9, which is 32. What? Oh! Do you guys see the substitution? This is u to the power of what? 16. And so now we have 16 u15. And so now we have 25 over 16 of dw 1 plus w squared. We have 25 over 16 of inverse tangent of w. What is w? U to the power of 16. What is u? X to the power of 25. X to the power of... No, I'm sorry, 16 over 25. Wow. And this integral here makes these Pythagorean triple exponents. How fancy. But don't let that distract you. Do not let that distract you. That's just MIT. Just dive right in. You know, ignore the formation that they make, and they just, you know, just simplify everything. And there you go. X plus cube root of x. Okay, let's see where this leads to. U cubed equals to x, 3u squared. Du is equal to dx. So we get 3u squared du. U cubed plus u. Alright, and this will give us 3 u du u squared plus 1. Oh, okay, not so bad. So then this is just a basic u substitution. This will give us 3/2 of u squared plus 1. U is equal to 1/3. U is equal to x to the power 1/3. I mean, so this would be this answer here. Okay? This looks terrifying. Please do not try to conjugate this. Do not conjugate this. Please. As I know you want to have fun showing off your Math Olympiad tricks, but let's not do that, just for the sake of respectfulness. So 3u squared du is equal to dx. Then we have u plus 1, and we have u minus 1 times 3u squared du. Okay, first of all, I need to deal with this. I need to deal with this. U plus, let me change color actually, to just sort of see what's going on. U plus 1 over u minus 1. This is equal to, well, I need a minus 1 plus 1, so that this is now, that's a very bad handwriting. I need minus 1 plus 1. So that this is 1 plus 2 left over, u minus 1. So I use that u minus 1 to just cancel it out into 1. So this is what we have actually. Okay. So then in that case we have 3u squared, a free 3u squared, and then plus 3u squared times 2, don't forget that, and then u minus 1. So this is just some geometric polynomial division. So 3u squared, 6, u squared minus u, that's, so this would be u plus 1, 1 over u minus 1, right? And then everything now, this is just u cubed, 6u, this will be 3u squared, plus 6u, plus 6 ln of u minus 1. Okay? So now plugging back with u, our answer would be x plus 3x 2/3 plus 6x 1/3 plus 6 ln of x to the 1/3 minus 1 plus c. And that would be my answer. This looks like a mess. We have a 5th root here and a 6th root here. Okay, so that, I guess we're gonna need u to the power of 30, unfortunately. Right, 2 times 3 times 5, that's 30. So let that be x. Oh god. Yeah, I'm sorry. It's okay. Everything's gonna be okay. Everything's gonna be okay. So, u to the power of 30. So that's 6 times 3, that's u18. I'll put a parentheses here. Plus, and then 30 divided by 6, that's u to the power of 5. And then we have times 30, u to the power of 29 du. Where is this going? 30 divided by 2, that's u to the power of 15. Okay, first of all, 29 minus 15, that's 14. Okay, So we have 30, and then we have u18 plus u5, u14 left. Jesus Christ. And then adding this is what, 32? Is that 32? Plus u19 du? Okay, well, we just do power rule. So we have 30 over 33. I'm simplify that as 10, 11. And then u to the power of 33, that's x to the power of 33 over 30. Oh, it's a reciprocal. It's the reciprocal of our coefficient. Okay. And then we have 20, 3 halves, x to 20, 2/3. It's a reciprocal. It's a reciprocal. Okay. And that's our answer. Again, we have that 1/5, so we want to get rid of that. U to the power of 5 equals x. 5u4 du is equal to dx. And so now, this gives us 5u4 du, u5 minus u cubed. And then we're going to simplify this further, take away u cubed. This gives us minus 1 u squared. Okay, so it's just the basic 5/2 ln of u squared minus 1. And so plugging in u, our answer would be 5/2 of ln of x 2/5 minus 1. You can start to see a pattern that our coefficient reciprocates our exponent. Okay. Alright, this is our last integral for power substitution. I noticed that we have a 4 and a 3. So that means that we need u to be to the power of 12. So that it cancels out all of our radicals. And so 12u11 du is equal to dx. And so now we have, let's see, plug in u to the power of 12, that's u4, times 12u11 du. And then this would be u6 plus u cubed. Alright, let's divide everything by u cubed to simplify it. This would be 12. So you divide everything by u cubed. This would be u to the power of 12 left. And then u cubed plus 1. Disgusting. This is very nasty. Polynomial division, technically. But I don't want that. I prefer geometric polynomial division. So let alpha equal u to the power of 3, technically. So then we have alpha 4, alpha plus 1, right? So then this would be alpha cubed minus alpha square plus alpha minus 1 plus 1 over alpha plus 1. And then we just substitute u cubed back in. So that's pretty much what this is. Okay. So we'll go ahead and do that. Let me put 12 at the back. And so now we have u to the power of 3. So cubing that, that's u to the power of 9 minus u to the power of 6 plus u to the power of 3 minus 1 plus 1 over... Oh no! Are you serious? Well, I don't want to do partial fractions. So I guess I didn't realize how this would turn out. If I change 2 times 3 times 5, that's 30. That doesn't make it any better. Oh my god, why did I give myself this? Maybe I should have switched 4 here and 3 here. But you know, the purpose of this video was just for power substitution. So now that we know how power substitution works, you know, it's just to get rid of radicals. But get rid of radicals with including cube roots or nth roots. Doing this for substitution really simplifies this a lot. And as you can see, power substitution, it has a lot of geometric polynomial division involved. So again, you just have to get comfortable with that. So yeah, that's pretty much it. This is power substitution. It's not that hard, actually. It gets tedious and it gets annoying sometimes, but at least you know how this concept works. So it's a very helpful tool, and you will see it a couple of times in integration bees, but it is very helpful to use this in the back of your mind. So that's pretty much it. Thank you so much for watching, and I'll see you guys in the next part.